Finally upgraded my bandsaw. My old one, which some of you have probably seen in the videos, was severely lacking in a whole number of areas, and so it was a long time coming. But I grabbed this one from Timbecon. It has a bunch of really good features which just make the whole operation a lot safer, way more accurate, easier to use, and it means that it's going to be a machine that I get a lot more use out of. I feel like I was constantly kind of fighting with the inadequacies of the old bandsaw, so it's really good to have this one in the shop. And I've done a thorough setup on it. It's cutting beautifully straight lines, there's no wandering. So I'll just kind of go through some of the features and then talk about the setup pretty briefly, and yeah, get you started and show you what I like about it. So I needed a bandsaw that was going to have enough power for the work I wanted to do. So obviously, depending on what you're going to do and how big your shop is and what you can afford, you know, that's going to affect all of those features. But this bandsaw gives me about 350mm from the back of the machine here to the blade, and about 300mm high. So that height is probably way more than I need, but if you're doing really nice big veneers, you might be looking for something that gives you that kind of height, so it's nice to have that option. Now there are machines that are bigger than this, but there's also a lot that are way smaller, and this kind of seemed like a good middle ground for me. A couple of the features that I really like on this that certainly my old one didn't have, and plenty others of new versions don't have. Starting from the top, the way that this bandsaw sets the tension has a quick release lever. And so setting the tension is fairly simple by rotating the lever to increase or decrease the tension. All bandsaws will have some sort of knob like that allows you to increase or decrease tension that way. But having this quick release lever means that I can really rapidly remove all tension from the blade without having to rotate that knob multiple times. What it also means though, is instead of having to count the number of turns to find my correct tension again, I just pull the lever down and the tension is already set to where it was previously. So there's a couple of reasons that you might want to remove tension rapidly on the blade. First thing is, you want to really take off tension whenever you're not using the bandsaw for an extended period of time. So if you're out of the workshop for a week, lose the tension on the blade. Couple of reasons for this. Additional stress on the blade over long periods of time can add, it's called work hardening to the steel, and it will reduce the longevity of the blade. The second thing is, your big wheels here actually have a rubber band around them, and that has a slight canter, a slight curve on it, and it's important that that curve is preserved. Now if you put a bunch of tension in one location on that rubber strip, and then you leave the bandsaw for a couple of weeks, you're going to make an indentation, you're going to affect the shape of that rubber wheel, and that's going to make your bandsaw run less true and less straight and mess up with the alignment. So it's nice to be able to rapidly, without having to think about it too much, remove the tension from the blade. A really important feature on any bandsaw are these guides. Now lots of saws come with lots of different systems. My old one just had little metal blocks that could be adjusted. That was kind of the old style, and they just sat, you know, not quite touching the blade. With a lot of use they heat up. There was a bit of friction there. They're not great for the length of the life of your blade. Most commonly those are then replaced with something called cool blocks, which instead of being a little metal block, it's a little resin block that is impregnated with some sort of lubricant, so it runs a lot cooler on the blade, which reduces heat buildup in the teeth, which keeps your blade sharper for longer. Another really common method for bandsaw guides is to use bearings on both sides of the blade and behind the blade. Now that works really well in a lot of cases. Those bearings obviously spin if the blade comes in contact with them, which reduces friction. Some of the issues with bearings are two main things. They can easily fill up with dust and stop working, and then you'll have either a squealing bearing or a bearing that needs replacing because it's not spinning freely. The second thing is as those wheels turn onto the blade, they can actually compress resin from the timber, sap and sawdust onto the blade and make your blade dirtier and actually be pressing that material into the metal. So what this saw comes with is actually ceramic guide blocks. So they're much harder than the cool blocks, the resin blocks. they're not a spinning surface like the bearings, and they work really well for a number of reasons. They actually help clean the blade as it goes through. Even though they're not touching the blade the whole time, they're just next to it, they'll actually be cleaning the blade as it passes through. So any sap or any sawdust that might have caught on the blade from the timber is actually going to be cleaned away by those ceramic blocks. According to the company, the ceramic blocks that are used for these bandsaw guides was actually a compound developed by NASA. It's very durable, very heat resistant, and they just work wonderfully for keeping the blade really true. They'll last a really long time, and you'll probably never actually need to replace them unless you somehow damage them, which is unlikely in normal operation. So those are my two side guides for the blade. At the back, I also do have a bearing in this system, top and bottom, and so that just operates by, if the blade is pressed hard against it, it spins, and that reduces friction on the whole system. The last feature that stands out on this machine is actually something that I wish all of my machines had, which is a foot brake. Now, this brake here, it's really simple to use. It actually physically stops the spinning of the blade by applying pressure onto one of the pulley wheels down there, but it also cuts the power to the blade to ensure that the motor's not still running as well. Now, there's plenty of times just in normal operation, if I'm doing like some small tenon cuts and I'm doing a bunch of them, where I need to be able to remove debris from behind the fence, or I need to be able to change over to my next piece of timber, and I don't want to have to wait for the blade to fully slow down before I can get in there and do whatever I need to do, whether it's move the fence or move the guides. And being able to do this in a second and completely stop the blade just makes it safer and so much easier to use. The bandsaw is also an interesting machine in my workshop in that it's one of the quietest, and so all of the other machines are just so loud, it's so obvious when they're running, and you know, that adds to the terrifying nature of woodworking. But these are a lot quieter, which actually in some ways can make them a lot more dangerous because you don't have such a huge, obvious spinning blade. Even though it's right here, often it's hidden in the guard and you might not be able to see that it's going on. So, I mean, you've got to be really aware of this machine, and a really good habit, which I'm going to need to get into because this is new for me, is whenever I walk away from the machine, stop the blade. And that means that even if I haven't pressed the emergency stop, even if I haven't turned the machine off, it's actually cutting the power and stopping the blade at the same time. So, really great feature. Not all saws have them. Obviously, you can live without it, but for me, it just adds to the safety and adds to the ease of use of this machine. A couple other things to look for when you're purchasing a bandsaw. Just have a play around with the fence, make sure it moves smoothly, it's firm when it's pressed down, it has no wobble in it, and that it operates in a way that you like. It was especially important for me that I could actually make the fence perfectly true to the table, so good fences will have that kind of adjustment built into them to make sure that it can always be true and square. So this is smooth, there's plenty of ways to adjust it, and it does exactly what I need it to do. Another really important thing to think about is making sure that when the table tilts, that it is firm, it can be locked off in position, and then can take the weight of the timber in that raised position. So just have a play around with it and make sure it does that in a way that you're comfortable with again. So this machine, you just unlock these bolts here, and then you can raise or lower it. It does have a little protractor on the front. I need to calibrate that. Usually when I'm doing this kind of operation, I'll be double checking all of those measurements with my own protractor anyway. I like to use the protractor on the machine as a guide, but I always tend to double check this stuff. So the first thing that I did once I'd kind of put this machine together is I squared the actual cast iron table to the blade. So to do this, you need to have some tension on the blade. We're not worrying about the actual blade tension just yet. Just make sure there's some tension on there, it's nice and firm, it's not bending all over the place. And then get a good reliable square off to the table, and make any adjustments that you need to the hard stops underneath. In this situation for this table, there's a set bolt that I can raise or lower in really small increments, which will help me get the table perfect. So I like to check that from both sides. And that looks great. There are plenty of other ways to square a table, but this works for me. Some people use timber and do a cut from one side and a cut from the other. So, you know, explore the internet. There are many ways to do this, but I'm just using a square here. The second thing that I really wanted to do was make sure that my fence was exactly perpendicular to my table, to make sure that when I'm running timber, not hard faced against the tabletop, but against the fence itself, that I'm actually going to get square cuts. So this fence has the ability to adjust that in, again, really small increments, so it's really accurate. A good fence should have that. Make sure you've set that up. It's an easy thing to forget. You just kind of look at the fence and you assume that it's set up to the table. It probably isn't. Get that nice and square. Make the adjustments that you need to. Changing blades on most bandsaws should be fairly similar. You want to open both the doors, make sure the power's off obviously. Take all the tension off the blade. You're going to have to remove the throat plate and then remove the pin that holds the split table. Pretty much all bandsaws will have some version of that. And then you're just going to slowly bring the blade off from the side away from the table first, and then feed it through gently through that slot in the table. It's fairly straightforward. You might want to use gloves. The blade is sharp. Obviously. Now, when you put the blade back on, you just want to make sure that those teeth are facing forward and that the pointy bits of the teeth are facing down. They're pointing down into the table. That's the direction they're going to draw. So it's just the opposite process in reverse, and make sure you then replace the throat plate and your little insert pin as well. So the next step that you have here in setting up the blade is actually getting the correct position or the correct alignment on the wheel here. Now, my instinct, at least initially, before I knew what was going on with bandsaws, was to place the blade directly in the center of that wheel. That way it seems like it has the least chance of falling off or anything horrific like that. But actually what you want to do is set the teeth, or the back of the teeth to be precise, in the center of the wheel, not the blade itself. Now, the reason for this is if you're looking at the wheel front on, the top of the rubber wheel actually has a camber. It's shaped like that. The blade sits flat on top of that. Now, if the center of the blade is sitting on that camber, the blade can rock, but we actually want the teeth sitting on the top of that camber so that they're solid the whole way around. Now, all machines should have some adjustment to do this. If they don't, no, they will. They absolutely have to. What you can do is, I don't put full tension on the blade just yet. We're not worried about that. Just make sure that it's got enough tension to stay on there, usually maybe half the tension that they'd recommend or something like that. And you can just turn the wheel slowly. Now, the blade will position itself and you'll see where it's sitting. Right now mine's sitting way too far forward. So I use this little adjustment knob at the back here and I can tension that up slowly, and as I do, every few rotations that blade will move itself into the more appropriate position, which is the back of the gullet, or the back of the teeth sitting in the center of that wheel. Once that's in the correct position, I'm going to lock off this tension nut at the back so it can't move, and that's set. From then, we're going to add a bit more tension to the wheel to it's about the approximate correct tension as specified by the machine. Now, we will kind of test that on our own as well. And then spin the wheel again just to make sure that the adjustment of the tension hasn't messed with the alignment at all. I want to go on to talk about blade tension before we set these guide blocks. Blade tension, like a lot of things in woodworking, tons of different ways to get this set up. The absolute best way is to get a little tension gauge, which I don't have. Most woodworkers I know don't have them. They're fairly expensive. They're in the range of a couple $100. But there are plenty of ways to get the tension set up without using one of those, and I'll kind of step through them now. Most machines will have some sort of guide here that helps you kind of figure out the rough tension of the blade. Now, it's a sprung guide, so it's balancing a really heavy steel spring against the tension of the blade to try and determine that correct tension. But those springs lose some of their force over time, and so they're not always super accurate, but it's kind of a good place to start. So this blade is a half-inch blade, half-inch wide, and so, you know, as a general guide, I'm going to place this on the half-inch position, and that will kind of be roughly correct. But I also want to know if the machine is actually calibrated correctly and whether or not I need that much tension or whether it's not enough tension. Blade tension on a bandsaw is a trade-off. At the high end, with really firm tension, you've got a really stiff blade and really, really nice straight cuts in a perfect world. But the issue that you have with that is that you're putting stress on the blade and you will actually make your blade wear faster. You'll get stress in the actual steel of the blade itself, which could make it snap. It'll stretch the blade, which will then mess with your calibration. And so that's the issue with having it way too tight. At the other end, if you have it really loose, the blade can vibrate, it can flex all over the place and give you really inaccurate cuts that curve. So where we want to be is somewhere in the middle of that. Basically, we want the blade to be tight enough to give us a really nice straight cut and no tighter than it needs to be. With this machine, with this really new blade, I was able to bring the tension down really low and still get a really nice straight cut. But as the blade dulls a little bit, that might be a little bit more difficult and I might need to increase the tension slightly. You will also really need to increase the tension if you're cutting really hard timber or trying to do really tall rip cuts or resawing cuts. But then you might not want to leave that really high tension setting on the machine for a long period of time, again because it can deform the wheels and it can stretch the blade and put too much stress on the metal of the blade itself. So as a general rule, only make the blade as tight as you need to get a really straight cut. If you're not getting a straight cut, you could try tightening the blade, but you also want to look at your guide blocks to make sure that they're set up correctly because that'll really influence that as well. But if your guide blocks are set correctly, then just make the blade as tight as you need to get a really nice straight cut. So the two main methods that I've come across for tightening setting blade tension. The first one is depressing the blade with your finger slightly and just getting a real feel for how far it should flex. Now there's a point where you can press fairly gently without your finger going wide at the knuckle, and it will go, in this case, about 1/2 centimetre, something like that. It is really good to get a feel personally for your machine and what the tension feels like, but again, it's so subjective. You don't know how hard I'm pressing here. Maybe I'm just super strong, maybe I'm not. But also when you have a thicker blade, that tension's going to feel slightly different. Anyway, it's worth knowing what that feels like. Always do it on the back edge of your blade because that way it's not encountering any of the guides or anything, and you've got a constant length of steel that you're depressing and trying to deflect. The second method that I've come across that a lot of people find really useful is called the flutter method. What it involves is loosening the blade to the point when the machine is spinning so that you can actually see the blade no longer run straight and flutter side to side. Now, I tried this with this machine, but with this new blade and the wheels being balanced, I had to get the tension so low before I could get a flutter that I didn't find it super useful. So that's when I started setting the tension a bit low and doing some cuts and just raising the tension up until those cuts were really nice and straight. So you can check out the flutter method. There's a bunch of videos on that online. If you are going to use that method, you do need to remove the guide blocks to allow the blade to run really freely. Now, obviously, if you're going to be running the machine with low tension, you want to make sure that the blade isn't going to come off the wheel. So I would start at a reasonable tension like you would be expecting to use as guided by the machine, and then slowly bring that tension down until you see a little bit of flutter, then increase it back up again. And that, in theory, is a good position for blade tension. But as I said, on this machine, I didn't get a lot of it, so it wasn't a great guide. The last thing I want to do, and it's a really important step, is setting up these guide blocks. Now, regardless of whether you're using ceramic blocks like this or bearings, the procedure is more or less the same. There will be a set above the table and a set below, so you need to do both of them. Now, basic principles. Regardless of whether you're using ceramics or cool blocks or bearings, you want the two blocks on either side of the blade. You want to make sure that they are not engaging with the teeth. In fact, they should be behind the deepest part of the gullet or the trough in between those teeth. And I like to make sure that they are behind the deepest part of the gullet by about 1 millimeter, or by about the amount of deflection that a little gentle pressure on the blade will give. Because as you're cutting, wood is putting pressure on that blade, and you don't want that pressure to be then forcing those teeth behind the front edge of your ceramic blocks or your bearings. So even though your blade is perfectly straight, your teeth have a set. There are offset on either side, and that is a really small amount, but if you have that back inside the bearing or inside the block, it's going to flatten that set and mess with your blade, and you'll not be able to cut very well. So make sure that the guides on either side are behind that point. Now, you also, obviously, you don't want them pressing hard on the blade. You don't want to be adding any friction that doesn't need to be there. In fact, you don't want them touching the blade at all, but you want them really close. So often the good recommendation is about the thickness of a piece of paper, ideally. Now that will be the same if you're using ceramic blocks or cool blocks or bearings. I adjust these by just loosening off that set screw, and then I can move these from side to side. That allows me to do the position forward and back, and also side to side by messing with these different set screws within this mechanism. Your mechanism might be slightly different. I really like this one. It's easy to use and lets me do really accurate adjustments. So once you've got your position of your blocks on either side of the blade, making sure that you've got width of paper between the block and the blade on both sides, you then want to set your guide wheel, which is behind the blade. Now again, you have one of these above the blade in this mechanism as well as below the table here. What that bearing does is as the blade is deflected back when timber is pressed into it, it's actually going to hit that bearing, which is going to spin, reducing friction and stopping the blade from being pushed really far back, keeping it captive within those guide blocks on either side. Now there's a couple of different ways of setting this up that I've heard. The first way is pretty similar to the side blocks. You should leave about the thickness of a piece of paper between the back of the blade and the bearing. Now that seems to work for a lot of people. When I tried that, I actually found that I was getting a bit too much deflection, and the way that that was explained to me is that as the blade is being pushed back into that bearing, it's actually then forced to one side. So I moved the bearing back by about 1 millimeter, and it allows the blade to be pushed back into that mechanism without hitting up on a hard surface until you get a fair bit of pressure in there. But it's good to know, you want to keep it in there really nice and close. I've got mine about 1 millimeter back from the back of the blade. Just a couple other simple things. With the position of the bearing that sits behind the blade, you don't want the blade to be right in the center of the bearing. Well, you won't be able to anyway because there's a screw there. You want it to be as close to the edge as possible. This is just for reducing friction. Obviously, if it's closer to the center of the blade, as the bearing has to spin, it's got a lot more surface area in contact with the blade, which is going to give you more friction. If you put it right at the edge, you've got a really small surface area, and all of that force going down is transferred directly into that wheel spinning. Now, all of those setup tips for the top block also apply to the bottom guide mechanism. Only one last thing, which should be obvious: make sure that your guide mechanism in total is square to the blade. So there's no point having those guides really close to the blade if they're actually skewed. So just make sure that you've got that. Now, by putting those side guides really close to the blade, about the thickness of a piece of paper, I can tell if this thing is square or not, and you will be able to too. So those are the things you need to look out for. I usually do all of this operation about, 100 mil or so up from the table, because that is a really common height for me to cut. All guide mechanisms and blade guards will be different on different machines. Some might have a bit of play in different locations. This one's really nice and firm, but you don't want to be setting these at the absolute extreme of the lowest point or the highest point. That's why I feel like somewhere in the middle here, where I use the blade most often, is going to give me the most accurate settings for these guides. So a well-tuned up, well-functioning bandsaw is just so versatile. You'll get a ton of use out of it. If you want to know more about this specific machine, there was a link down below. I picked this up from Timbecon recently, so I'm really looking forward to doing a couple more videos on more specific uses on it, so check them out. But otherwise, get the most out of your bandsaw, set it up right, make it safe, make it cut efficiently. It'll be a machine that you just use all the time. Be your best friend.